System-wide information management 2. SWIM's service-oriented architecture SOA technology offers several benefits, including enhanced interaction between software applications in the National Airspace System and AS. SOA allows applications to communicate through information services without requiring knowledge of the underlying platform implementation. This simplifies interface requirements for existing NAS systems and facilitates the development of new systems with minimal technology constraints, leading to lower development and implementation costs and risks. SWIM's SOA supports the transition to net-centric NAS operations, moving from tactical conflict management to strategic, trajectory-based operations. The key benefits of implementing SOA in the NAS include business and information technology alignment, adaptability, interoperability, reuse, and scalability. SWIM facilitates the reduction of passenger delays and flight congestion by enabling users to request, receive, and publish information as needed. This efficient access to current information enhances decision-making, streamlining shared information for improved planning and execution. Consequently, there is a potential for fewer delays at major airports and a reduction in airlines' fuel costs by avoiding unnecessary reroutes around severe weather. SWIM is expected to reduce costs and save taxpayers money by minimizing infrastructure costs through a reduction in unique interfaces between systems. New systems will use SWIM-compliant interfaces, leading to lower development costs for future data interfaces. This approach aims to eliminate the need for redundant data sources and allows for the decommissioning of associated systems, contributing to overall cost efficiency and savings for taxpayers. SWIM enhances information sharing for improved planning and execution, benefiting airlines and air traffic controllers. Users can access up-to-date information more efficiently, leading to better decision-making. SWIM contributes to reducing delays at major airports, alleviating flight congestion, and lowering fuel costs for airlines by avoiding unnecessary reroutes due to severe weather. The system also enhances situational awareness for air traffic controllers. The SWIM Visualization Tool SVT is a specific SWIM application that has proven advantageous for the FAA's Southern California Terminal Radar Approach Control TRACON Facility SCT. Some benefits of SVT include improved traffic management coordinators TMC ability to quickly understand aircraft departure release times based on taxiway queues. Enhanced ability of TRACON to comprehend and manage airspace demand using aircraft and data block color coding. Coordination of airspace for departures and arrivals in opposite directions, facilitating better understanding of traffic flow. Confirmation of landings in adverse weather conditions, providing insights into low-altitude surveillance tracks during heavy rain. Situational awareness of airport surface traffic complexities caused by anomalous events such as runway closures or disabled aircraft. Coordination and confirmation of aircraft ready for departure during high-demand conditions, improving airspace management and reducing communication between TRACON and towers. Indeed, SWIM is poised to enhance aviation safety by fostering greater common situational awareness. The program enables multiple decision-makers to access identical information, providing consistent data to diverse users such as pilots, controllers, and dispatchers. This consistency supports proactive decision-making and contributes to overall improvements in aviation safety. SWIM provides substantial benefits to various FAA stakeholders, enhancing data sharing efficiency and reducing implementation and operating costs as information is consolidated into a single system. The program also amplifies opportunities for collaborative decision-making (CDM) and facilitates the decommissioning of outdated legacy systems. In this way, SWIM supports the ongoing transformation of the National Airspace System (NAS). SWIM implementation serves the dual purpose of enhancing internal operations within the U.S. and fostering cooperation with other air navigation service providers (ANSPs) globally. The program was designed as a technology enabler to establish information technology standards, infrastructure, and governance for National Airspace System (NAS) systems. SWIM promotes information sharing, improves interoperability, and encourages the reuse of information and services. The vision is to create common processes and infrastructure for next-gen, making aviation data more accessible to stakeholders, both within and outside the United States. The FAA has already demonstrated collaboration by providing SWIM data to National Air Traffic Services (NATS) in the United Kingdom and is actively working with Eurocontrol for further international connections. This collaboration enables better management of air traffic operations and enhanced cooperation between nations and the NAS. SWIM, being a ground-to-ground communication system, does not require any onboard equipment. There is no mandate for SWIM equipage, and as such, airlines do not need specific onboard equipment for SWIM. The focus of SWIM is on ground-based communication, and there is no estimated cost for equipage related to airline ground equipment. The on-ramping process duration for SWIM implementation varies for each consumer. Generally, it takes between 2 to 6 months, depending on the time needed for the consumer to develop a mature interface to SWIM and obtain approval for data consumption from the NAS Data Release Group. SWIM governance is the application of service-oriented architecture (SOA) governance within the SWIM program. It aims to establish enforceable policies, procedures, processes, tools, and organizational activities to ensure the integration of independent SOA-based efforts, aligning them with FAA/NAS business objectives. Key functionalities of SWIM governance include developing standards, policies, and procedural guidelines, operating the NAS Service Registry/Repository (NSRR) to make services discoverable, conducting SOA suitability assessment procedures, providing a uniform understanding of SWIM concepts, advancing international understanding of SOA, and supporting outreach activities for awareness and training. SWIM requires specific software as many service-oriented architecture SOA protocols are not on the wire, offering multiple implementation options that align with the standard's intent. For instance, the Java Message Services (JMS) protocol may be implemented differently by various vendors. SWIM adheres to industry standard formats to ensure interoperability and compatibility across different systems. The NAS Service Registry/Repository (NSRR) is a vital SWIM-supported feature that enhances the visibility, accessibility, and understanding of services across the National Airspace System (NAS). Functioning as a centralized repository, NSRR holds information about all existing or under development SWIM services. It offers a flexible mechanism for service discovery, automated policies for managing services throughout their lifecycle, and a catalog for relevant artifacts. SWIM governance policies mandate that all SWIM-enabled service providers must register in the NSRR. Being SWIM compliant entails that applications and systems adhere to specific IT standards and SWIM policies to ensure accessibility and interoperability. Compliance categories include data compliance, SOA service interface compliance, service messaging and transport compliance, and SWIM programmatic compliance, each having associated standards and policies to guide adherence. There is no obligation to subscribe to every SOA service. Depending on the service, there are additional filtering options. For specific details on filtering for each SWIM SOA service, please refer to the NAS Service Registry Repository NSRR. If you have more questions about obtaining data through SWIM, you can easily submit data requests for SWIM data by following this link. SWIM encompasses the NAS Enterprise Messaging Service NEMS infrastructure and data exchange standards. The ownership of data within SWIM belongs to the different entities that collect or produce the data. SWIM itself does not own the data. One of the main challenges in implementing SWIM is meeting the increasing demand for on-ramping additional data publishers and consumers. The flexibility of the SWIM network, offering NAS air traffic management operational content, has led to a surge in popularity and an expanding consumer base. Key data types, including airport surface information, accurate flight tracking, and digital notices to airman NOTAMs, contribute to this demand. The FAA is actively working to provide data access to over 200 individual consumers, both domestically and internationally. Keeping up with data interoperability and governance is another significant challenge for FAA SWIM. Staying current with international data format interoperability standards like FAXM, AIXM, and WXXM is crucial, as well as adopting and supporting international messaging standards such as the new 2014 AMQP version 1.0. Addressing these challenges is vital for ensuring the effectiveness of SWIM. The data communications system enabled by SWIM is primarily designed to be automated and operate in a machine-to-machine environment. SWIM currently concentrates on ground-to-ground messaging interactions. SWIM is one of the 5 key next-gen programs, playing a crucial role in connecting FAA systems and facilitating interaction with other stakeholders in the aviation decision-making community, including government agencies, air navigation service providers, and airspace users. SWIM is not primarily an air traffic control ATC tool, rather, it enables the aviation community to access real-time, relevant information, fostering collaboration opportunities with industry and the international community. While SWIM and digital voice communications are components of the FAA telecommunications infrastructure FTI network, the SWIM infrastructure itself will not be utilized for digital voice communications. Net centricity involves a networked community of individuals, information, and services aiming to optimize resources and maximize benefits. It shifts from standardized point-to-point interfaces to a many-to-many exchange model, allowing multiple users and applications to leverage the same data. The objective is to make information and capabilities easily visible, accessible, and understandable. SWIM contributes to net centricity by facilitating the sharing of NAS information among users. Thank you for watching.